Today you trained a humanoid to walk like a person by showing it human motion, and you asked exactly the right question. How does it know to move like the video? Does it watch the clip and copy what it sees? It does not. The robot never sees the video at all. There is no understanding and no watching. What actually happens is simpler and far more clever. Let's open it up. First, a problem. The motion comes from a human body, but the robot is not shaped like a human. Different limbs, different proportions, 29 joints instead of a skeleton. So before training even begins, we run a one-time conversion called retargeting. It takes the human motion capture clip and rewrites it as robot joint angles. The human's walk becomes a table of numbers the robot can actually be measured against. You did this with a tool called GMR on a public dataset of recorded human motion. The result is your reference file, the answer key. Think of it as a table. Down one side, every moment of a single walking cycle. Across the top, all 29 joints. Each cell says, at this instant, this joint should be at this angle. That is the entire human demonstration, frozen into target angles. The robot is no longer chasing a video, it is chasing a spreadsheet of poses it should hit moment by moment. Now the key idea. As the robot moves, at every single step we compare its current pose to the pose the answer key says it should be in right now. We measure the error, how far off each joint is. Then we turn that error into a score with one formula, e to the minus error squared. Read it like this. 0 error gives the maximum score of 1. A small error, still a high score. A large error, and the score collapses towards 0. Perfect match, full marks. Way off, almost nothing. This single number is the imitation reward you watch climbing during training. And here is the part that surprises people. The learning algorithm does not understand walking, or humans, or even what the score means. It has exactly one drive. Make the total score as large as possible. It tries actions, sees which ones raise the reward, and pushes in that direction millions of times over. Because the reward is highest when the pose matches the answer key, maximizing the score and imitating the human turn out to be the very same thing. The human-like walk is not copied. It is discovered as a byproduct of chasing points. This has a name, motion imitation or reference motion tracking. The original recipe is a landmark paper from 2018 called Deep Mimic, which used exactly this. Reinforcement learning plus an imitation reward, indexed by the phase of the motion. Almost everything modern is built on it. In our own paper library, 0WBC and Humanoid Gym use the same structure, the same e to the minus error squared form you are using. You are running a direct descendant of Deep Mimic. So here is the whole answer in one line. The video is converted once into a table of target joint angles. Every step, the robot is scored on how closely it matches that table. The algorithm blindly maximizes the score, and a human-like walk falls out. It is a student copying a teacher's pose for the grade, without ever understanding the teacher. And it works. Your imitation run climbed past reward 21 and looked natural, while plain reward shaping got stuck near 15, walking like it was drunk. That gap is the whole point.